Okay. Good evening, everyone. So we're going to be looking at data presentation. Now, the assumption is that you've already had a class that looked at the measures of central tendency, measures of dispersion. So we'll look in summary at how you present data. Look at how you present data. So how do you present? So you have information, you have probably summarized it. How do you present it? How do you present data? So some people say there are three ways of presenting data. I like to add that there is a fourth, and there is a reason for that. You can either present data as a write-up, as a prose, or you can present data numerically in numbers, or you can have a table. That's what we mean by tabular. And you can develop a graph to use and present your data. So I want to explain prose before we go into I want to just explain it and dismiss it before we go into the details. What prose refers to is a write-up. You are writing. For example, and prose usually oftentimes does not stand on its own in data presentation. It is often used as a way of explaining or drawing attention to the salient points that are coming from a table or a graph, oftentimes. So if you have ever seen the result section of any work, you would probably see tables, and then under the table, above the table, depending on what your discipline and your instructions are, you would see a write-up that sort of tries to explain the content of the table. There are other times where the way the data set is, the only way for you to make it make sense to somebody else is to write it in prose. But this is not often the case. This is seldom the case, but sometimes you will need to use only prose to explain. Every other way will be too cumbersome, will be too complicated. You just need to say, there are three persons as data. There are three persons in the class. How do you want to now do a table for three persons? It's just telling me, just say there are three persons in the class. One male, two female. That's prose. That is explanation. So it's going to be a bit ridiculous for you to start doing a table or a graph for something as small as that. Okay. The other way you present data is numerical. Give us the numbers. And oftentimes it also goes with proportions. So frequency and proportions. You can pick or just frequency. So for example, the prevalence of HIV in Nigeria, it's just saying it off the top of my head, is currently 3.1%. Prevalence of HIV in Nigeria is currently 3.1%. Now, that doesn't sound like it's a big problem. Yeah. Well, if I say that over 5 million Nigerians are living with HIV, that is, I've just brought up numbers. Prevalence of HIV equal to 5 million. Rather than saying prevalence of HIV is 3.3%, I've said prevalence of HIV is 5 million. I can also say 3.3%, in bracket 3.3%. What that tells me is that the numbers create some form of visual about what is going on with regards to what is happening. So it's also another way of presenting data. Very commonly, we use tables and also we use graphs. So let's move and look at some of the characteristics of numerical data presentation, tabular data presentation, and graphical data presentation. What are some of these instances and situations where you have when you need numerical presentation of data? If you remember when you probably would have done some class on measures of central tendency, you remember the median, you will first have to arrange the data sets in ascending or descending order, and then identify the middle route, the middle number out of the data set. The way you need to arrange and organize the data set by ascending or descending order is numerical presentation. Another way is the use of measures of central tendency, where you have a figure. Mean is this number, the median is that number, the modal number is this. Or measures of dispersion, where you say the range, so the standard deviation, the variance, the interquartile range, the percentile. It's just a value, a number, but that number gives you an understanding of what is happening in the data set. Very often we use tables. So tabular presentation. So tabular presentation is very important. Tabular presentation is very, very, very important. So you have three types of tables. And I mean, we're going to do, all of you are going to be involved in research work. You will very often use tables to present your results. You can have a simple table, you can have a frequency distribution table, and you can have an analytical table. Let me show you. Let me explain what I mean by simple table. In a simple table, you just have numbers. You just have numbers. So for example, in a table where you have, you used a table, you have the data on one column. That's the data set on one column. You have the measure of central tendency, mean, median, mode in another column. That's a very simple data. Simple table. There isn't anything much apart from the fact that there are numbers and they are arranged in rows and columns for you to have some sense of what's going on. We often do not use simple tables. What we often use are frequency distribution tables. A frequency distribution table is a table in which you have the number, that is a particular value of a variable, the number, and you have the number of times that value occurs. So let me give you an example. Your class, assuming that your class is total of about 800 persons, you have a large class, and you have 450 males and 350 females in your class. If I were to do a frequency distribution table for the sex distribution of members of your class, the table would look something like this. The variable will be sex. You have the two options, it's dichotomous. You have the two options, male, female. Then in one column, the second column will be the frequency. So the number of males, 450, that's the frequency. The number of females, 350, that's the frequency. Then in the third column, you probably would have the percentage or the proportion. So what proportion is 450 over 800 times 100? Slightly over 50%. So maybe 52, 53, 54%, 55%. I've not done the math, but somebody can do it and let us know. And the same thing for the females, it will be about 40 something percent. That's a frequency distribution table. It has the numbers, and it very often has the proportions. You go on to have an analytical table in which you have more than frequency distribution. You also have more than the frequency distribution. You also have the statistical analysis that refers to inferential statistics. So when you look at the relationship between variables and you have the analysis of what that relationship is. So in an analytical table, for example, you probably have something like a chi-square value and along with its corresponding p-value, or you would have done a t-test, so you have t-test value along with its corresponding p-value, or you would have calculated confidence interval, and then that confidence interval, along with the upper 95% confidence interval, upper and lower, you will have all that information. So that's an analytical table. Why do we need tables? You want to condense data into an easily understood form. If the example we're using about the sex distribution of members of this class, 800 of you, how long will it take me to explain to somebody I'm trying to explain the distribution of sex in this class, to say number one person, Mr. So 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 is a male, then the other person, Miss so 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 is female, then the other person is a male, then the other person is a female, and you just go on and be droning on. That's frustrating. Nobody will be able to give you that energy, that time, that effort. But what I've just said is you have a count of the number of males and a count of the number of females. And you tell us 450 males in this class and 350 females. Some sort of analysis has been done to get that information. In addition, you can now do your proportions and now find out what the percentage of males are in this class and what the percentage of females are. So it summarizes, it makes it easy for you to handle data, especially large volumes of data. All right, let's look at graphs. Let's look at graphs. Another word is diagram, another word is graph, another word is chart. Diagram, graph, chart. Those are the three words that we use. So we build charts with lines, area, and text. Oftentimes you build a chart with line, area, and text. A chart is appealing to the eyes. You can quickly understand information from a chart. It gives you a bird's eye view of the data. It helps you to see some shapes and symmetry, to see whether the data they have similar characteristics or they are so divergent that there is no characteristic that connects them. So it is very, very useful. However, the disadvantage of charts is that it can tend to hide some important information. Some important information can tend to be lost when you are using a chart or a graph, as against when you are using a table, you can have a lot more detailed information than you want to do with a chart or a graph. The other thing is that when the number of the values of the variable is large, you need a different type of chart to be able to to be able to present it compared to when the values are few. Some examples of the charts that we use. One, a pie chart. A pie chart is like what you can see on this screen. It's a circle shaped like a pie. It's a circle, and a quadrant of the circle is equated to the frequency of occurrence of an event. So, for example, if you're doing a pie chart for male, female, so sex distribution, male, female, gender, you can have a pie chart that shows that 55% of the study population are males, while 45% are females. All you need to do is when you have that your circle, equate 55% to 360. What will that give you in degrees? I bet it will be slightly more than half. If you say male is 55%, it will be slightly more than half of the 360 degrees. It will be slightly more than 180 degrees, maybe 200 degrees from your pi. So it takes that. And then the other female being 45%. So it's clear, you can see it. Another type of chart you can do is a bar chart. It's a bar chart. Now, a bar chart is useful when the values of the variable that you want to summarize, the values of the variables you want to summarize are discrete. Discrete means they stand on their own, no one dovetails, no one value ends and starts at the same time. No one's value. So it's very clear. So example, if we're going to do a bar chart with the number of children members of this class have. So between 0 and 1, between 2 and 3, between 4 and 5. What you're going to do is one child, you will have a bar by itself. I want two children, a bar by itself, three children, a bar by itself, four children, a bar by itself. And then the height of the bar is equivalent to the frequency of occurrence of the number of persons that have that number of children. I will get to show you in a bit what a bar chart looks like. Another type of chart is a histogram. So a histogram, basically, a histogram is used to represent continuous data. While a bar chart is discrete data and data that has frequency and frequency distribution. A histogram is quantitative, continuous data measured on the interval and ordinal scale. So what do we do with that type of situation? You do a histogram. So for example, weight. If I'm going to describe the weight of members of this class, I would use a histogram because one person's weight dovetails into another person's weight and all of that. So I'll just have weight and I would all the weight, and you'll find out that everybody's weight will be in what we call a histogram. Some people's weight will be lower, some people's weight will be higher, and so on and so forth. Very, very important. Yeah. We have other types of charts, but let me stop here for now. I'll take a couple of questions, then we can look at a practical exercise that would show us what those charts look like. So if you have a question, kindly put it in the chat box, please. Thank you. I'll be watching the chat to see if I can take 2, 3, 4 questions and then we make progress. Questions? Hold on. I'm reading in the chat that you have not learned measures of central tendency and you have not learned measures of dispersion. I need a class rep to confirm.
It's true, ma. It's true.
Really?
What
I'm not the one
really
blocking anybody
happened
from
was,
speaking. No, that's your class rep. But he can speak for all of you. I don't need everybody talking. Class rep, can you please unmute and confirm to me? That means you've had only one class in statistics, or you were
exactly.
not
We've
in
had only one
class.
class. No, we've had only one class. We were
Okay,
supposed
now
to.
I'm
Dr.
expecting an
Sumeri Abi
answer.
was supposed to teach us that.
Yes, he's speaking. We've had just
Since I'm
one
not
class.
hearing.
That
Okay,
was
I'm not
last week.
hearing. Oh,
Can you hear
sorry,
me?
I wasn't hearing you all this while. I can hear you now. Go ahead.
Okay. So we just had one class last week, and Dr. BA is saying he will come back next week to continue.
It doesn't make sense. I cannot start teaching you inferential statistics if you've not learned descriptive statistics. It does not make any sense. So we will switch gear. Good enough. This topic is still introductory, how you present data, but we'll switch gear and go to the basics of statistics and we'll look at descriptive statistics. All right. So I have you for at least another 1.5 hours. So that's exactly what we will do. I hope that is fine. When ABA comes, he can pick up. I'll tell him where I stopped. He can pick up from where I stopped. All right. Let's go back to basics. I want to know, Ikenna, what did you learn? What was your class, the one class you had? What was it about?
Okay, so the class was on Introduction to Statistics, where he talked about datum and the components of datum. He went ahead to talk about the types of variables. So that was all.
All right, that's fine. Okay, thank you very much. No problem. We can always make things happen. Let's step back because it's mission impossible and extremely confusing and annoying to try to teach you. Um, okay. So did you learn scales of measurement? Did you learn
Yes, that
scales
was
of measurement?
yes, that was part of the first slide. Yes, it was there. That was the last thing.
Oh, that's fine. Okay. 1 second. Let me get my slides. And do you have reading materials like a textbook or something? Recommended text.
Okay, for now we don't have textbooks. He just gave us slides that refers us to the topics assigned to him.
No problem. So I will do that. Recommended texts as well. Okay, so we'll start with a refresher on scales of measurement. Then I'll take you to descriptive statistics. We should be able to conclude to a large extent descriptive statistics today. All right. Okay, so this is just a short class on scales of measurement in statistics. So you would need to identify variables and know what scale these variables are being measured. What is a variable? What is a variable? A variable is any characteristic, measurable characteristic that has the ability to change value from one unit of the population to the other. Any measurable characteristic that has the ability to change value from one unit of analysis or unit of the population to the other. So, for example, sex is a variable because sex can be male in one person and female in another person and male in the other person and female in another person and so on and so forth. Weight is also a variable because weight can take up a different value from one person to the other. Same thing with height, same thing with temperature, same thing with blood pressure. Most biological characteristics have variability. So between one unit of analysis, one individual, one population, one unit of the population or the other, they change. The reason why I'm explaining variables is that you need to understand what a variable is first before you talk about scales of measurement of variables. How do you measure variables? So 4 major ways of measuring variables. And these 4 ways of measuring variables lead to categorization of variables in 2 categories. Number 1 way of measuring variables is that you have some variables that in and of themselves are measured on a nominal scale. Nominal means by name only. By name only. For example, sex, treatment type, blood group. All right, by name only. So you can have the ones that are just 2 categories, options are possible. Only 2 categories are possible. They are called dichotomous variables. Only 2 categories. There are some that I have 3 or more categories, like blood group. Yeah, they are called categorical. Categorical is a general name. A special type of categorical is dichotomous. What type of analysis can you do with nominal variables, which is like by name only? They don't really tell you anything about relationship between one group or the other. They just say male. And even if you put numerical values, like I said, and in coding, when you want to code, you could give numerical values. Male will be 1, female will be 2. It doesn't really mean that 2 is higher than 1 or 2 is better than 1 or 2 is any way different from 1. It's just by name only. What do you do? What type of measurements can you do with nominal scale measurements? It is frequency and proportions. That is the type of summary statistics you get. It's frequency and proportions. So, for example, how do you summarize the sex of people in this class? You say 5 people were males and 10 were females, which means that X percentage were males and Y percentage were females. And that's the best you can do. With ordinal scales, there is a name, a nomenclature, a name given to the various values of a variable. But in addition to a name given to them, there is some level of ranking, some order in which these variables appear. So, for example, disease severity, mild, moderate, severe. BMI categories, underweight, normal weight, overweight, obese. Blood pressure categories, normal blood pressure, elevated blood pressure. Type 1 diabetes, type 2, type 1 hypertension, type 1, type 2, type 3, there's still anything like that. So you see the grading. Medical house officer, medical officer, registrar, senior registrar, consultant, professor, like that. There's a ranking. So you know that one is on a higher rank than the other, but you don't have a numerical value for what separates one rank from the other. You do not have a numerical value for what separates one rank from the other. You know that one ranks higher. Likert scale, for example, is a typical ordinal scale. Likert. Three scale Likert or 5 scale Likert, like Professor Best was talking to us about. Assume it's a 5 scale Likert. You know that very strongly agree is on a higher level than agree. But by how much? Can you give it a numerical value? No. For most of the time, we will give numerical values to the 5-scale Likert and say 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4. Simply for the sake of analysis, simply for the sake of coding or for making sense, or even to show that there's an order and one is higher in order than the other. But by how much, you don't know, and you really can't find out numerically. How do you analyze ordinal scale variables? What measures of summary? What summary measures do you use? It's the same as nominal. You would use frequency and proportions or percentages. That is the same thing you would do, frequency and percentages. Whole numbers and proportions is how you would summarize. How do you present the data when you've summarized it for nominal or ordinal scale? What's the best way of presenting? You can do tables, and those tables are called frequency tables. Or you can do charts. So pie charts, if it is 2 categories, 3 categories, 4 categories. When it starts getting to 5, 6 categories, a pie chart is no longer the best. You may want to use a bar chart. You will want to use a frequency polygon. You will want to use a histogram. There's so many different charts that you can use for nominal and ordinal scale. Not even a histogram, sorry, a bar chart, not a histogram. Histogram is better for continuous variables, please. I'm making that correction. All right, that's fine. Then the next two, very important, interval and ratio scale. All right. So interval and ratio scale. With interval, there's ranking, there's name, there's rank, and then there is an attribute of by how much more and by how much less. So you can actually do subtractions and additions. So for example, this temperature measured in degrees centigrade or degrees Fahrenheit, not Kelvin. Temperature measured in degrees centigrade or degrees Fahrenheit. If you walk into a room and it's 16 degrees, and you come out, the bedroom is 16 degrees, the parlor is 19 degrees. You can say the parlor is 3 degrees warmer than the bedroom. And you'll be very correct because there's a numerical value to the difference between one temperature and the other. However, you cannot say if the temperature in the room is 16 and the temperature in the parlor is 32, you will not be correct, even though people say it centigrade, you will not be correct exactly to say the parlor is twice as hot as the room. Why? Centigrade or Fahrenheit don't give you true zero values. Please, you can go back and read it, check it up. They don't give you truth because a 0 degree centigrade is not the absence of heat. It's just what you are able to measure. It is Kelvin scale of measurement that gives you an absolute or a true zero. And then when that takes us to ratio scale, and they are analyzed the same way because they are both continuous variables. I'll talk about that in a bit. Ratio scale, values, it has name, it has values, it has ranking, and there's a true zero, which means that multiplication and division is possible. So things like weight, height, age, they are all ratio scale values because you can talk about somebody being twice as heavy. You can talk about the blood pressure being twice as high. You can talk about the temperature in Kelvin being twice as high or the temperature here being half what it is there. And you can do that. What type of analysis? Measures of central tendency for interval and ratio scale. Measures of central tendency are summary measures rather, for interval and ratio scale are measures of central tendency and measures of dispersion. So this is where you can do mean, mode, median. This is where you can do histograms. This is where you can actually do standard deviation, interquartile range, percentiles, and so on and so forth. So you can do all of that. So if, for example, your objective is want to compare the weight of one group with the other, immediately you know that the type of analysis that you're going to do is mean or median. That's what you're going to do with standard deviation or interquartile range. That is exactly what you would need to do. And so you will not be seeing any table that has frequency and percentage for an objective where the outcome variable, the main variable there is weight. The same way you will not be seeing mean and standard deviation where the outcome variable is perception of something, good perception, poor perception, or even if you want to rank the perception, and say strongly, like at it. It cannot take up main mode media. It has to be frequency and percentages. So that is why I said what I said. You must understand the variable or know the scale of measurement of that variable when you are setting up your data analysis table or your data analysis plan. All right. All right. I'm sure that helped you to clarify and made it a bit clearer. Great. So we can make progress. If we have questions, put it in the chat box. I'll take the first 10 questions that I see. We'll respond to them. So it's fastest fingers. Take the first 10 questions. Just send your questions. I'll take a couple of questions, then we'll go to measures of central tendency and measures of dispersion. A pivot table is an analytical table. It's an analytical table. David, there isn't much to elaborate on. Degrees Celsius, centigrade, and Fahrenheit are scales for measuring temperature. But these scales for measuring temperature are not able to measure the absolute absence of heat. They are relative scales. They are not absolute scales. They are relative scales. They are not absolute scales. So while interval and ratio are very similar, there are a few situations where even though the variable has numerical value, even though the variable, there's order, there's ranking, it has a name, it has an order, it has numerical value. But because there is no true zero, you cannot multiply or divide that variable. The best you can do is add or subtract. You can say that outside is a certain number of degrees hotter than inside. You cannot say that 40 degrees is twice as hot, 40 degrees Celsius is twice as hot as 20 degrees Celsius. You really can't say that I know sometimes people say, but you really can't say that in actual fact. Because centigrade, Celsius, Fahrenheit, they don't have true zero. But Kelvin can measure, that's Kelvin scale. It can measure the absolute absence of heat. When we calculate for practical purposes, interval and ratio scale are taken as continuous variable and done together. A nominal and an ordinal variable are very different. Nominal variable that is by name only. 1 second, someone is calling. Nominal variable that is by name only. For example, sex, male or female, ethnic group, hair color. You just call the name. That's the only way to express the value of that variable by giving us the name. Very simple. However, when you are doing that, there is no sense that blue is different from black, but there is no sense of superiority between blue and black. But with ranking, there is a sense of superiority. Ordinal gives you an order, which is the same as a rank, and superiority is involved. So there's a higher degree of severity for moderate as compared to mild, and for severe as compared to moderate as compared to mild. There's a higher degree for a PhD as compared to a master's. So there is order. So even though it is a name, for example, mild, moderate, severe is a name, but that name connotes some type of order. So that is the difference. Chi-squared, if that's what Esther is trying to type, is not, I don't know what you mean by discrete or continuous distribution. Typically, if I understand what you're saying, chi-squared distribution is discrete, it's not continuous. Typically, if I understand what you're saying. And it's non-parametric most of the time. All right. What else? So with ratio scale, what we are going to be able to do with ratio scale is that you can see an increase in the value of the variable from one unit of the population to the other. And you can also see an increment by a factor. So for example, weight and height are variables on a ratio scale. Weight and height are variables on a ratio scale. Somebody can be twice as big or twice as tall as somebody else. So that's really how these things work. It is important to understand it. It's important to understand it so that you can, this is actually the building blocks. If you are doing descriptive statistics and you want to summarize data, you need to know what type of variable it is. A different kind of variable is amenable to a different method of summarization. Qualitative variables are summarized in a different way from quantitative variables. So nominal, ordinal are both called qualitative, while interval and ratio are both called quantitative. And the way you will summarize them is very different. For practical purposes, we group ordinal and nominal together for the sake of the type of way you will summarize it and the type of inferential statistics that you will be able to do with it. While interval and ratio are, for all intents and purposes, grouped together as quantitative variable or continuous variable. And there's a different way you would summarize it. And even when you are doing inferential statistics, there's a different set of statistical tests that you would use. So I took the pains to come back here because for me, this is the foundation. You understand scales of measurement and you're able to apply it, then you are doing a great job so far. All right, let's move and go to another discussion around descriptive statistics. All right, quantitative data has four major ways you summarize it. Four major ways you summarize it. Two of these ways are the most popular, but there are four major ways. One is by summarizing using measures or techniques for central tendency. Measures of central tendency. The next one is measures of dispersion, otherwise measures of variability. Third is measures of relative position, otherwise called quantiles. And the final one, quantiles or percentiles. So if I put those two side by side, relative position, quantiles or percentiles. And then measures of distribution of the shape, the skewness and the kurtosis. I will explain what that means as we go along. Just take note of that for now. So let's look at measures of central tendency. I'll come back to this one, but let's just look at measures of central tendency. Three major ways central tendency is measures of central tendency, three major values: mean, mode, yeah. I'm sure we have heard of this over and over again. Mean, mode, median. Mean is the average. We add up the values of the variable from individuals, units in the sample, and you divide it by the total number of individual units. Mean height, for example, is keep a record of all the people whose heights you are interested in studying. You record down all their heights. You count the number of people in that sample. So, for example, let's assume there are 20 in that sample. I've found the 20 of them. You got different heights in meters. You got different heights in meters from these people. There are 20 of them. So, when you say mean height, you would have added up all the values for height in that class are divided by 20. That's what this n means. The sample, the size of the sample. This thing that looks like, I think it looks like an E, but it's not exactly an E. It's summation sign. No, it's a summation sign. So whenever you see this, it looks like you're adding up. So this is adding up. X is the value representation of the individual value. X. So X for me, when I talk about height, may be 1.5 meter, while X for Precious may be 1.7 meters, and so on and so forth. So summation XI, which means that each individual has their X. The summation of that divided by the total sample size, that gives you your mean. Median is the number in the middle, the middle ranking number. All right, sorry about that. So the middle ranking number, which means that you have to rank. And ranking means you will arrange the numbers from the smallest to the largest, or from the largest to the smallest. So that is, you're going to rank. And the one that of course happens to be the middle number, which is identified by n plus 1 divided by 2, where n is the sample size. Number of participants in your study is your n, number for number. And then so the total number of persons. For example, there are 20. There are 20 in this class from the last one we did, when we had to calculate mean. And 20 in this class because we used as denominator. So in this case, you have n plus 1 divided by 2. So that is 10.5. So the middle, when you rank all the numbers in that data set from the smallest height, the shortest to the tallest, there will be a number. There will be a try to identify that 10th number. And then you also identify the 11th number. So your median lies between number 10 and 11. And then, of course, there's something you can do about it. You add up at the value for 10 plus with the value for 11 and divide by 2. Mode most frequently occurring number, most frequently occurring number. So if the value of a particular variable may occur more than once in the distribution, it's a distribution. So each of these have their advantages and disadvantages. Simple to calculate. So we're talking about the mean. It's simple, easy to calculate. It's very useful in a lot of other statistical analysis and calculations. It is really representative of the population because you are studying the entire, you're studying, it's representative because all the values are there. So you are involving, your calculation involves all the values. You can't take one and leave the others, the way median and mode does. This one involves all the values. So mean is actually quite very, very, very good at presenting the population. Right, so that's advantage. Disadvantage is what you can see. Non-statisticians find it a bit difficult to understand the concept of the mean. Mean value may not always represent the actual scores. And it's affected. The major thing here is that extreme values mess up your mean. So, for example, remember the issue of central tendency. You still have somebody whose height, we're talking about height of people in class, somebody whose height is 2-point-something meters, double. It will push, because once you add 2-point-something meters to the entire equation, we're trying to find what's the mean age. It was the mean height value. A very high value will push your mean to push it to one corner. Either skew it to the right or skew to the left. Median, also very easy to calculate. It's important we bring in median when we now have extreme values, or we bring in median when the population, the distribution in the population does not follow the normal distribution curve. And at some point, we will learn about the normal distribution, or what's called the Gaussian curve. Of course, it just picks up one or two numbers and works with them. So no dealings or relationship with all the others. So it may not truly be representative. Mode, the last in the series of 3. Very easy for you to calculate mode. But mode is not always representative of the population because you do not use the entire set of values. But the advantages are have extreme values. You can neither skew more to the left or to the right. It's easy to calculate. Okay, so let's take questions. Questions, please. Let's see a couple.
Thank you very much, Prof. Hello, ma.
Go ahead, please.
Okay, when you were explaining mean, median, and mode, I saw the formula you is on the screen for median. That is n plus 1 over 2. What you get there, then you arrange the values from the smallest to the highest. Then you can't. Then if it's in between, maybe for instance you use a number of 20. Then you are thinking about maybe 10 and 11, then you divide by 2 to get the median. I thought that formula applies for even numbers. I just want to find out. I think that formula, I was thinking that formula applied for even numbers. Because for odd numbers, you can easily arrange from smallest to the highest. You just pick the middle number.
All right, thank you. So Ogochukwu, if you have a small data set, 10, 12, 30, 50, you can arrange from ascending to descending, and whether they are even or they are odd, that is the total number, the n, the sample size, whether it is an even number or an odd number. You can still calculate manually your median, your median. What are you going to do? If it is 50 that is in the sample size, and you've arranged it in hierarchy, whether it is ascending or descending, it doesn't matter. You go to the 25th and 26th number. You record the values of the 25th and 26th position, add it and divide by 2. If it is an odd number like 49, so you have 24 on one side, 24 on the other side, it is the 25th number that is your median, once you have arranged it in ascending and descending. That is where the formula is coming from. That formula, n plus 1 divided by 2. The n is not the values, the values of the numbers. The n is the rank, the order, the nth number. So for example, is for 50. Your sample size is 50. 50 plus 1, 51. Divided by 2, 25.5. So you are looking for the 25th 0.5 number. Not, I don't know if you get it.
Yes, I understand what you're saying. What if you are looking for like for instance, you have a set of number that is 49. Will you still apply this
49
formula?
plus 1, 50. 50 divided by 2, 25. Exactly the 25th number.
5th number, okay.
25th number
all right.
in the rank.
Number, the rank, okay. All right, I understand now. Thank you very much.
So that formula works for everything. So it's useful. The formula becomes useful when you have a large data set. How do you want to be arranging? All right. So if you are using, for example, maybe Excel, you just ask it to order, and then you put equal to n, which is the sample size. You collect the whole row plus 1 divided by 2. So if it is half, because they always give you a half, 10 and a half or 25.5, it means that the 25th and the 26th, the numbers in the 25th and the 26th rank, you must add them and divide by 2. That's what it is.
Right. Okay, ma. All right. I understand, ma. Thank you very much.
Any other question? Thank you. What statistical decisions can you make with the median value? Olatunji, calm down. We'll get there. When we get there, you start to see, all right, why that when you are using median, there are some statistical tests that you do with median. Rather, if you are using mean, it's a different set of statistical tests. And so it's possible that a data set, I'm answering and you now. It's possible that a data set will not have a mode. It is possible that a data set will not have a mode. Very possible. So there is mode is the most frequently occurring. A data set may also have 2 modes or even 3 modes. So if I'm in median, you will always need to arrange in descending and ascending order because the ranks take position from hierarchy. You will always need to arrange. But of course, if you're using statistical software, the statistical software will go and rank by itself. We do not now need to arrange it. Excel, SPSS, whatever software you want to use. Just the same way you say equal to mean. And once you select the data set, it will just output the mean for you. It has done the math. The same thing with media. No, I don't intend to teach grouped data sets. If Dr. Abie comes on board, ask him to take that with you since he gave you that. I don't intend to teach it, and I honestly don't think you need it. Let's make progress. So let's now look at frequency distribution. So remember, measures of central tendency are for quantitative data. Quantitative data. So does that mean that we don't have a way to summarize qualitative data? We do. And that's the next thing I'm going to take us through. So when we talk about distribution, we refer to the pattern observed in the collection of values for a variable. There is always a pattern. Those values, there's a pattern they follow. And so you would try to look at that pattern is what the concept of distribution is all about. Now, there are 2 different kinds of variables, 2 different classes of variables, and the distribution of variables in the way we're going to learn it now is related specifically to variables measured on a nominal and an interval scale, otherwise known as qualitative variable. So this particularly refers to qualitative variable in which numerical values are assigned to phenomenon that is going on. So if you have qualitative data, I'll give you an example of qualitative data. Sex, age group, not age. Age is quantitative. Age group is qualitative. BMI categories is qualitative. Tribe, religion, these are all qualitative. You can say that BMI stage 1, 2, 3, 4. You can label it like that, where 1 means underweight, 2 means normal weight, 3 means overweight, 4 means obesity. You can label it like that. So you see, I'm saying this means that, this, that, that. But you are not really, those numbers are not really what you can do any serious mathematics with. You can't do a mean, you can't do standard deviation. That's not how that variable is measured. It's measured on a nominal or an ordinal scale. So what can you do? You can do a frequency distribution. You can do a frequency distribution, and you can summarize in frequency and proportion. Frequency and proportion. So you have 4 types of distribution for qualitative data. 4 types of distribution for qualitative data: frequency, relative frequency, cumulative frequency, cumulative relative frequency. I'll just go through them one after the other, so that if you actually do come across this kind of tables, you will understand. Isn't something to be too bothered about. Okay, so this table, I'm trying to make you understand what we just referred to on the last slide. So the table that you can see is a distribution of parity among women with ovarian cancer. So we have a set of women who had ovarian cancer. You want to know how many children they've had. Parity is number of children that somebody has conceived. So let's know what your parity. How does, so each woman that comes and you ask about parity, and parity for these women is between 0, no child, to more than 5 children, as you have been asking. Now you want to know what the frequency is. Now look at that. First of all, total number. So this is frequency, which is just count. The first column, frequency, refers to count, just a count. How many women have never had a child? 15. How many women have only one child? Have had only one child? 11. How many have had 2? 8. How many have had 3? 6. How many have had 4? 5. How many have had more than 5? 5. Total number of women in the sample is clearly shown here as 50. So that is that. Now, when you talk about relative frequency, you are going to have to convert that whole number into a percentage. Of course, 50 is equal to 100%. So 50 is the entire sample. So it's equivalent to 100%. So what is 15 out of 100? Simply do 15 divided by 50 times 100. 11 divided by 50 times 100. 8 divided by 50 times 100. So you can see why it is 16. 6 divided by 50 times 100. You can see why it's 12. And so on and so forth. And by the time you add it up, it comes up to 100. So whilst frequency is you dealing with the whole numbers as they are, relative frequency is you dealing with them as a proportion. In fact, preferably as a percentage. Cumulative means adding up on top of what you already have. So to accumulate, you are collecting it and you are adding it up as you go along. So for cumulative frequency, what happens is that the frequency that you currently have plus the immediate past frequency are added together. So let me explain. Frequency of women who have had 0 child is 15. Frequency of women who have had 1 child is 11. 15 plus 11 gives you 26. 26 plus 8 gives you 38. 38 plus 6, 34 rather. 34 plus 6 gives you 40. 40 plus 5 gives you 45. 45 plus 5 gives you 50. So you can do the cumulative plus equal easily. And then there's cumulative relative frequency. This one has to do with the percentages that you had worked out earlier. So the first one is 30, the second one is 30 plus 22, which is 52, and so on and so on. So that's what a frequency distribution table looks like. Now, how do you display a frequency distribution. You either use a table, like we had just done, or you innovate and come up with a graphical form of presenting your data. A graphical form of presenting. So, I'll come back here. Let's just look at different ways of presenting, depending on the kind of data set you are dealing with. Okay. So we can say a bar chart. I do not need to explain what a bar chart is. The fact that you have on the x-axis, the horizontal axis is always x. You have on the x-axis different colors. You can see different colors. You can see blue, gray, green. So you have this. You have that. Then the height. So individual bars represent the different issues, the different measurements. So we want to know how many people have brown eyes, blue eyes, gray eyes, and something like that, eye color. Then the y-axis, which is the vertical axis. My cursor is going up and down there. The y-axis is supposed to be the frequency count. So the numbers as observed. So you can see that the majority is, and it's so easy, a bar chart is so easy to interpret. Very, very, very clear because it's there. It's there. If done properly, choose. And it's easy to understand. So it's easy for me to explain that about 75, that's why I trace it somewhere about there. 75 of the study participants had brown eyes. Blue is looking like 20 of the study participants had brown eyes. No. Gray, you can see maybe like 2 or 3. And green, not at all. I think green is just one person that has that eye color. So that bar chart tells you quite a bit. It's very, very, very informative. It also hides some things, and we'll come back to look at that. This is a pie chart. So it assumes that all study participants, for example, have a variable that is categorical or even dichotomous. Sex, for example, male and female. So I ask how many males are in this class, how many females are in this class, and we use that to develop a pie chart. So a pie is just a circle covering 360 degrees, and the frequency, relative to the frequency of that particular item or that particular characteristic needs to be divided by 360 or divided by the total. So the number of, for example, if there are 150 and 100, which is 250 people in the class, just like this pie shows us, 150 of them are females and 100 are males. What does this translate to? It translates to 150 over 250. Remember, that's 2 times 100. That will be about 60%. So when you're doing that, you have to give more space because it's not equal anymore. You have to give more space for. So you can see straight line. will be 50-50. It's 60-40. And you can see your graphs should always be properly labeled, and you should always have a key. You can see I have male, female. And the frequency alongside the percentage should be displayed in the pie chart. Let's move. All right, a histogram. The histogram is a frequency. So a histogram here, you can see that histogram. Histogram measures continuous data, variables that are measured on a continuous scale, like weight, for example. And you see the frequency. Because it's continuous, you see that one bar laps perfectly with the next, and so on and so forth. Very different from the bar chart, in which you have discrete values and discrete variables that are separated. So this is another way of presenting the data. So I'll pause again and see whether we will take a few questions. All right. Anything cumulative is you add the older one to the newer one. You add the older one to the newer one. So if it's cumulative frequency, if the first frequency was 5, let's just say male and female, 5 males, 10 females. Frequency for males is 5. Frequency for females is 10. The first that's under frequency. Under cumulative frequency, the first one will be 5. That's the first. You start with the first. Then the second one will be 15, because you are adding the new frequency, the one for females, you are adding it to the male. So you are cumulative. The word cumulate is to add together. Is to add together. Right. And the next one is 12. You add, just keep adding. You just keep adding. Honestly, the usefulness of cumulative frequency is to see whether your frequency is more useful for cumulative frequency percent or cumulative frequency proportion, to see whether it will add up to 100%, or if it will add up to the total sample size. With cumulative frequency, you want to see if you're adding up, you add up to the total sample size, because at the end of the day, the last figure in your cumulative frequency table is the sample size. Everybody together. So we looked at measures of central tendency. We looked at how to summarize. We looked at measures of central tendency. We looked at how to summarize data that is qualitative, also how to summarize data that is quantitative. We've looked at all of that. Let me see what else I'd like to share with you before we call it today. So I guess that the very first lecture I gave is making a bit more sense. That's my guess, my hope, when we talked about presentation of data. Once you know the scale of measurement of data, of a particular data set, it becomes easy to understand how to present it. Okay, so I want us to talk about measures of dispersion. We've talked about measures of central tendency. We've talked about frequency distribution. Let's talk about measures of dispersion. And that will conclude descriptive statistics. Can a pie chart be likened to data presentation on a histogram or a bar? I don't know what you mean by likened. I don't know what you mean by likened. Um, I'm not quite sure what you mean by likened. Ima, your hand is up.
Yes, thank you very much. My question is just clarifying from Dr. BA's class. Per the slides, there are things like percentiles and interquartiles and docile and all that different topics that's not been covered. I recognize and I appreciate you overviewing this for us. My question is, does this mean he's no longer going to go over all of the other things he's giving us materials on, or does this mean you're just giving us like a preamble of what he would come back to complete?
Thank you. I don't have an idea what Dr. BA will or will not do. I guess you'll need to take it up with him. All right, let's go to
he will definitely hold the class with us.
let's go to measures of dispersion. Measures of dispersion. Let's go to measures of dispersion. Second.